Good morning, sir. This is UVN3 I am going to explain the digital assignment 1 according to microcontroller application. In digital assignment, we have the total 10 questions. I am giving clarity about each and any. The first question is to analyze the Intel of i3, i5, i7 processor microprocessing element and compare their features based on their concept. And this is the block diagram of the microcontroller and IP. This is the central unit to as you know, CPU is the brain of any processing device of the microcontroller, and the interrupt its name suggests in a subroutine called the temple solve microcontroller main operations. And you can see int or tf are there, and the memory microcontroller requires a program which you want to store everything in its memory simply. And bus is a collection of the wire which works as a communication channel and medium for transfer data. Here in this it carry 8, 16 and 8 bit simultaneously. Two buses are there, address bus and data address bus, 16 address bus, and data bus is microcontroller 8 bits data, it is 16 and 8 bit. And oscillator we know general device, therefore it requires clock pulses for its operation microcontroller applications, and input and output port. Normal microcontroller used in embedded system, and these are the timers 8051 is system bit timers and counters. And second one, the instruction set of microprocessing or microcontroller IP core with clock required and machine cycle required and memory required. As in the 8051 family of microcontroller 8 bit processor, the 8051 microcontroller set as the optimized 8 bit control applications and 8 bit processor, and you can see it came up to power 82 instruction. And this is the data transfer instruction, a data AR direct and description addressing note. And logical instruction we also have one table, you can observe that. The next group of instruction logical instruction perform logical and or XOR get clearly swap performed on base, and this is the table. Boolean or by multiple calculation table, can see. And this route question was the XM microprocessing and microprocessor core architecture. In the following diagram, the bus connects all the support devices to the CPU. The system bus consists of 8 bit or system bit address bus control signals. All other devices like program it together the system bus. You can see the interrupt controller, everything is there. And this is the 8051 ports. These are pin 1 ports. And they clearly explain from pin 1 to 8 and pin 0 to what is the use of it. This is again you can here so you can IP interrupt register. These are the table. And the fourth one is the create a microprocessing element architecture, which discussed in the module 1 and 2. This is the internal architecture. We connect to the control signal address data, and they need to go to then the form to internal data bus Y to LAN, and here VCC will connect, and the pin 0 pin 1 connect and read port pin. This is the port 0 pin, and you can see it is the pin 1 is the port 1 pin, and 2 port 3 and port 3 pin. And it is the output latch of the 1 bit of the data, and this diagram is the showing 1 or 0 at the output. You can observe here 1 0 1 0, and this is the reading from the port pin of the port 1, and this is port 1 same figure, sorry. And these are the every figure we discussed the above. And the fifth question, compare the organization of the RAM ROM memory organized processing memory with our project ISN module 2. And these are the 889 C51 LP51 at 889 C51 VL52 memory structure. You can observe memory logical prioritization. You can see in the figure, this figure shows the program memory after reset the CPU beginning execution from the location 0000H, and in each interrupt assigned is a fixed location program memory. The interrupt causes CPU to jump to that location, execute the service routine action, usually in service routine. So you can observe everything interrupt locations, and these are the 8 bytes. Each byte is written here, and this is last one is called reset. And this is the clear explanation of the diagram. This is the executing from the external memory, and the executing data memory program available as IO input. And this is the internal data memory and 128 bits of internal RAM, and this is the figure 9 128 bits, and this is the SFR space. The sixth question is to compare the amount of the time of the complex instruction all the processing elements you can compare at 89 IP 89 C5 first to DCSC 500 everything. And this is the complete table of each and every one. And external program memory read cycle, external data memory read cycle diagram, external data memory cycle, and external clock drive waveform. And this is the table of the external clock drive, and this is the table of serial port timing shift register mode to test conditions. And seventh question is to peripheral interface available and performance type of peripherals in module 5. And this is the CPU, memory, and peripherals. And peripheral device can boldly be classified into type and categories, and general purpose and special purpose. This is the simple input 8255, 8259, 8237, and 8251, again 8253, 8253 program. And this is the special functions, or you can see this diagram, and the LED interface into the micro description of the LED, and the segmentation interfacing circuit, and the serial communication enter programming. And these are the methods of the serial communication, and everything USART, UART, everything will come in this under this. and the ADC, DAC and sensor to signal conditioning explanation available in all processing elements. And given this question was from the module 7, you can see the ADC experiment, DAC and signal conditioning, and the advantage of peripheral interfacing, and this is the arithmetic operators table, and logical operators, Boolean multiplication, data transfer, and the last question was to control load format of the special functions register Intel i3, i5, i7, and PCON S1, and this is the table of that, and this is the diagram we want to know that, and this is the main 64-bit RAX here, and the EAX, everything is explained here. And this is the construction register input output mode, and this is the IP PV controller which is asked in the question. This is the PSW, and this is the PCON and SCON, TMOD and TCON, everything was written briefly here. Thank you, sir.